Okay, so let's do number 3. In number 3, when you balance the equation, you end up getting something like that. Now, it tells you that you're starting with 12.475 liters of methane, okay? And it wants to know how many molecules of carbon dioxide are you going to have. So, again, there's nothing about limiting reagents that you have to find. So this is just kind of like one-to-one problem. So I'm going to set up from what I know. I know I have 12.475 liters of methane. Then I'm going to say, okay, if I want to get rid of liters at the top, then I have to have that at the bottom. That's per 1 mole. Then that's where I get to the mole conversion. So I'm going to say, okay, the mole ratio. So I'm going to say, all right, so if I, in my problem, if I have 1 mole of methane, so I'm going to have 1 mole of methane, then how many moles of the one in question do I have? I only have 1 mole of carbon dioxide as well. So mole of methane and mole of methane is done. I don't have anything about methane anymore. Now I'm going over to the carbon dioxide side. I have 1 mole of carbon dioxide. Then I want to know how many molecules are formed. So my ratio then is for every 1 mole, I have 6.02 times 10 to the 23rd particles or molecules or atoms or wherever the case may be. So that's what I have. And when you solve it out, I am going to have, cancel those two things out. Then I am going to have something like, let's see, so 12 divided by 22 times by 6.02. So I am going to have 3.35, one more, 2 times 10 to the 23rd molecules of carbon dioxide, okay? All right, the next problem is asking, then given the same situation, what's the volume of oxygen that's needed? So I do the same thing, start with what you know, 12.475, okay, liters of methane, CH4. Same thing here, want to get rid of that, so put 22.4 liters of methane down here. Okay, cancel, cancel. I said that's per every 1 mole of methane, right? We know that from like back in the days when we did the ratios. So then I say, all right, according to our problem, how many moles of methane do I have and how many moles of oxygen do I have? Well, I have 1 mole of methane. For every 1 mole of methane, I need 2, according to my problem, moles of oxygen. So those two things are canceled. Well, if that's the case, then what's the volume of oxygen that's needed? So I'm going to say 1 mole of oxygen goes down here, so I can cancel them out. Then the volume thing, again, is the 22.4, right? For liters of oxygen. That's the conversion ratio. Then that's it. So the only unit that's left over is liters of oxygen. So you multiply straight across and divide. Then the answer you get is something like 24.95. 950, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 of oxygen. Okay? All right.